Section 5. Airbrakes. This section covers airbrake system parts, dual airbrake systems, inspecting airbrakes, using airbrakes. This section tells you about airbrakes. If you want to drive a truck or bus with airbrakes, or pull a trailer with airbrakes, you need to read this section. If you want to pull a trailer with airbrakes, you also need to read Section 6, Combination Vehicles. Airbrakes use compressed air to make the brakes work. Airbrakes are a good and safe way of stopping large and heavy vehicles, but the brakes must be well maintained and used properly. Airbrakes are really three different braking systems: service brake, parking brake, and emergency brake. The service brake system applies and releases the brakes when you use the brake pedal during normal driving. The parking brake system applies and releases the parking brakes when you use the parking brake control. The emergency brake system uses parts of the service and parking brake systems to stop the vehicle in a brake system failure. The parts of these systems are discussed in greater detail below. 5.1. The parts of an airbrake system. There are many parts to an airbrake system. You should know about the parts discussed here. 5.1.1. Air compressor. The air compressor pumps air into the air storage tanks, reservoirs. The air compressor is connected to the engine through gears or a V-belt. The compressor may be air-cooled or it may be cooled by the engine cooling system. It may have its own oil supply or be lubricated by engine oil. If the compressor has its own oil supply, check the oil level before driving. 5.1.2. Air compressor governor. The governor controls when the air compressor will pump air into the air storage tanks. When air tank pressure rises to the cutout level, about 125 pounds per square inch, or psi, the governor stops the compressor from pumping air. When the tank pressure falls to the cut-in pressure, about 100 psi, the governor allows the compressor to start pumping again. 5.1.3. Air storage tanks. Air storage tanks are used to hold compressed air. The number and size of air tanks varies among vehicles. The tanks will hold enough air to allow the brakes to be used several times, even if the compressor stops working. 5.1.4. Air tank drains. Compressed air usually has some water and some compressor oil in it, which is bad for the airbrake system. For example, the water can freeze in cold weather and cause brake failure. The water and oil tend to collect in the bottom of the air tank. Be sure that you drain the air tanks completely. Each air tank is equipped with a drain valve on the bottom. There are two types: manually operated by turning a quarter turn or by pulling a cable. You must drain the tanks yourself at the end of each day of driving. See Figure 5.1. Automatic. The water and oil are automatically expelled. These tanks may be equipped for manual draining as well. Automatic air tanks are available with electric heating devices. This will help prevent freezing of the automatic drain in cold weather. Picture Figure 5.1 showing a manual draining valve at the bottom of an air tank. Continuing with the text. 5.1.5. Alcohol evaporator. Some airbrake systems have an alcohol evaporator to put alcohol into the air system. This helps to reduce the risk of ice in airbrake valves and other parts during cold weather. Ice inside the system can make the brakes stop working. Check the alcohol container and fill up as necessary every day during cold weather. Daily air tank drainage is still needed to get rid of water and oil, unless the system has automatic drain valves. 5.1.6. Safety valve. A safety relief valve is installed in the first tank the air compressor pumps air to. The safety valve protects the tank and the rest of the system from too much pressure. The valve is usually set to open at 150 psi. If the safety valve releases air, something is wrong. Have the fault fixed by a mechanic. 5.1.7. The brake pedal. You put on the brakes by pushing down the brake pedal. It is also called the foot valve or treadle valve. Pushing the pedal down harder applies more air pressure. Letting up on the brake pedal reduces the air pressure and releases the brakes. Releasing the brakes lets some compressed air go out of the system, so the air pressure in the tanks is reduced. It must be made up by the air compressor. Pressing and releasing the pedal unnecessarily can let air out faster than the compressor can replace it. If the pressure gets too low, the brakes won't work. 5.1.8 Foundation brakes. Foundation brakes are used at each wheel. The most common type is the S-cam drum brake. The parts of the brake are discussed below. Brake drums, shoes, and linings. Brake drums are located on each end of the vehicle's axles. The wheels are bolted to the drums. The braking mechanism is inside the drum. To stop, the brake shoes and linings are pushed against the inside of the drum. This causes friction, which slows the vehicle and creates heat. The heat a drum can take without damage depends on how hard and how long the brakes are used. Too much heat can make the brakes stop working. S-cam brakes. When you push the brake pedal, air is let into each brake chamber. Air pressure pushes the rod out, moving the slack adjuster, thus twisting the brake camshaft. This turns the S-cam, so called because it is shaped like the letter S. The S-cam forces the brake shoes away from one another and presses them against the inside of the brake drum. When you release the brake pedal, the S-cam rotates back and a spring pulls the brake shoes away from the drum, letting the wheels roll freely again. See Figure 5.2. Illustration, Figure 5.2. Caption reads, Drum brake. Highlighted items reading clockwise from the top: brake chamber, slack adjuster, adjusting nut, brake cam, cam roller, brake, brake shoe lining, return spring, axle, brake drum. Continuing with the text. Wedge brakes. In this type of brake, the brake chamber push rod pushes a wedge directly between the ends of two brake shoes. This shoves them apart and against the inside of the brake drum. Wedge brakes may have a single brake chamber or two brake chambers, pushing wedges at both ends of the brake shoes. Wedge-type brakes may be self-adjusting or may require manual adjustment. Disc brakes. In air-operated disc brakes, air pressure acts on a brake chamber and slack adjuster, like S-cam brakes. But instead of the S-cam, a power screw is used. The pressure of the brake chamber on the slack adjuster turns the power screw. The power screw clamps the disc or rotor between the brake lining pads of a caliper, similar to a large C-clamp. Wedge brakes and disc brakes are less common than S-cam brakes. 5.1.9 Supply pressure gauges. All vehicles with air brakes have a pressure gauge connected to the air tank. If the vehicle has a dual air brake system, there will be a gauge for each half of the system, or a single gauge with two needles. Dual systems will be discussed later. These gauges tell you how much pressure is in the air tanks. 5.1.10 Application pressure gauge. This gauge shows how much air pressure you are applying to the brakes. This gauge is not on all vehicles. Increasing application pressure to hold the same speed means the brakes are fading. You should slow down and use a lower gear. The need for increased pressure can also be caused by brakes out of adjustment, air leaks, or mechanical problems. 5.1.11 Low air pressure warning. A low air pressure warning signal is required on vehicles with air brakes. A warning signal you can see must come on before the air pressure in the tanks falls below 60 psi, or 1/2 the compressor governor cutout pressure on older vehicles. The warning is usually a red light. A buzzer may also come on. Another type of warning is the wigwag. This device drops a mechanical arm into your view when the pressure in the system drops below 60 psi. An automatic wigwag will rise out of your view when the pressure in the system goes above 60 psi. The manual reset type must be placed in the out-of-view position manually. It will not stay in place until the pressure in the system is above 60 psi. On large buses, it is common for the low-pressure warning devices to signal at 80 to 85 psi. 5.1.12 Stoplight Switch. Drivers behind you must be warned when you put your brakes on. The Airbrake system does this with an electric switch that works by air pressure. The switch turns on the brake lights when you put on the air brakes. 5.1.13 Front Brake Limiting Valve. Some older vehicles, made before 1975, have a front brake limiting valve and a control in the cab. The control is usually marked normal and slippery. When you put the control in the slippery position, the limiting valve cuts the normal air pressure to the front brakes by half. Limiting valves were used to reduce the chance of the front wheels skidding on slippery surfaces. However, they actually reduce the stopping power of the vehicle. Front-wheel braking is good under all conditions. Tests have shown front-wheel skids from braking are not likely even on ice. Make sure the control is in the normal position to have normal stopping power. Many vehicles have automatic front-wheel limiting valves. They reduce the air to the front brakes except when the brakes are put on very hard, 60 psi or more application pressure. These valves cannot be controlled by the driver. 5.1.14 Spring Brakes. All trucks, truck tractors, and buses must be equipped with emergency brakes and parking brakes. They must be held on by mechanical force because air pressure can eventually leak away. Spring brakes are usually used to meet these needs. When driving, powerful springs are held back by air pressure. If the air pressure is removed, the springs put on the brakes. A parking brake control in the cab allows the driver to let the air out of the spring brakes. This lets the springs put the brakes on. A leak in the air brake system, which causes all the air to be lost, will also cause the springs to put on the brakes. Tractor and straight truck spring brakes will come fully on when air pressure drops to a range of 20 to 45 psi, typically 20 to 30 psi. Do not wait for the brakes to come on automatically. When the low air pressure warning light and buzzer first come on, bring the vehicle to a safe stop right away while you can still control the brakes. The braking power of spring brakes depends on the brakes being in adjustment. If the brakes are not adjusted properly, neither the regular brakes nor the emergency and parking brakes will work right. 5.1.15 Parking Brake Controls. In newer vehicles with air brakes, you put on the parking brakes using a diamond-shaped, yellow push-pull control knob. You pull the knob out to put the parking brakes, spring brakes, on and push it in to release them. On older vehicles, the parking brakes may be controlled by a lever. Use the parking brakes whenever you park. Caution: never push the brake pedal down when the spring brakes are on. If you do, the brakes could be damaged by the combined forces of the springs and the air pressure. Many brake systems are designed so this will not happen, but not all systems are set up that way, and those that are may not always work. It is much better to develop the habit of not pushing the brake pedal down when the spring brakes are on. Modulating control valves. In some vehicles, a control handle on the dashboard may be used to apply the spring brakes gradually. This is called a modulating valve. It is spring-loaded, so you have a feel for the braking action. The more you move the control lever, the harder the spring brakes come on. They work this way so you can control the spring brakes if the service brakes fail. When parking a vehicle with a modulating control valve, move the lever as far as it will go and hold it in place with the locking device. Dual parking control valves. When main air pressure is lost, the spring brakes come on. Some vehicles, such as buses, have a separate air tank which can be used to release the spring brakes. This is so you can move the vehicle in an emergency. One of the valves is a push-pull type and is used to put on the spring brakes for parking. The other valve is spring-loaded in the out position. When you push the control in, Air from the separate air tank releases the spring brakes so you can move. When you release the button, the spring brakes come on again. There is only enough air in the separate tank to do this a few times. Therefore, plan carefully when moving. Otherwise, you may be stopped in a dangerous location when the separate air supply runs out. See Figure 5.3. 5.1.16 Anti-lock braking systems, ABS. Truck tractors with air brakes built on or after March 1, 1997, and other air brakes vehicles, trucks, buses, trailers, and converter dollies, built on or after March 1, 1998, are required to be equipped with anti-lock brakes. Many commercial vehicles built before these dates have been voluntarily equipped with ABS. Check the certification label for the date of manufacture to determine if your vehicle is equipped with ABS. ABS is a computerized system that keeps your wheels from locking up during hard brake applications. Vehicles with ABS have yellow malfunction lamps to tell you if something isn't working. Tractors, trucks, and buses will have yellow ABS malfunction lamps on the instrument panel. Trailers will have yellow ABS malfunction lamps on the left side, either on the front or rear corner. Dollies manufactured on or after March 1, 1998, are required to have a lamp on the left side. On newer vehicles, the malfunction lamp comes on at startup for a bulb check and then goes out quickly. On older systems, the lamp could stay on until you are driving over 5 mph. If the lamp stays on after the bulb check or goes on once you are underway, you may have lost ABS control at one or more wheels. In the case of towed units manufactured before it was required by the Department of Transportation, it may be difficult to tell if the unit is equipped with ABS. Look under the vehicle for the electronic control unit, ECU, and wheel speed sensor wires coming from the back of the brakes. ABS is an addition to your normal brakes. It does not decrease or increase your normal braking capability. ABS only activates when wheels are about to lock up. ABS does not necessarily shorten your stopping distance, but it does help you keep the vehicle under control during hard braking. Picture, Figure 5.3. Caption reads, Tractor Protection Valve and Emergency Trailer Brake Operation. Tractor Protection Valve provides air supply, closes automatically if air supply drops when driving. The parking brakes, when equipped, close the tractor protection valve and set the spring brakes at the same time. At the top, the tractor protection valve is blue and round. On the control handle reads Brakes Release, Pull to apply, Push to hold. The tractor protection valve is an octagon and red. Tractor protection, pull to apply, push to release. The parking brake handle is diamond-shaped and yellow. It is lettered Parking Brakes, Pull to apply, Push to release. Continuing with the text. Subsection 5.1. Test your knowledge. 1. Why must air tanks be drained? 2. What is a supply pressure gauge used for? 3. All vehicles with air brakes must have a low air pressure warning signal. True or false? 4. What are spring brakes? 5. Front wheel brakes are good under all conditions. True or false? 6. How do you know if your vehicle is equipped with anti-lock brakes? These questions may be on your test. If you can't answer them all, reread subsection 5.1. 5.2. Dual air brake. Most heavy-duty vehicles use dual air brake systems for safety. A dual air brake system has two separate air brake systems, which use a single set of brake controls. Each system has its own air tanks, hoses, lines, etc. One system typically operates the regular brakes on the rear axle or axles. The other system operates the regular brakes on the front axle and possibly one rear axle. Both systems supply air to the trailer, if there is one. The first system is called the primary system. The other is called the secondary system. See Figure 5.4. Before driving a vehicle with a dual air system, allow time for the air compressor to build up a minimum of 100 psi pressure in both the primary and secondary systems. Watch the primary and secondary air pressure gauges, or needles if the system has 2 needles in one gauge. Pay attention to the low air pressure warning light and buzzer. The warning light and buzzer should shut off when the air pressure in both systems rises to a value set by the manufacturer. This value must be greater than 60 psi. The warning light and buzzer should come on before the air pressure drops below 60 psi in either system. If this happens while driving, you should stop right away and safely park the vehicle. If one air system is very low on pressure, either the front or the rear brakes will not be operating fully. This means it will take you longer to stop. Bring the vehicle to a safe stop and have the air brake system fixed. 5.3. Inspecting air brake systems. You should use the basic 7-step inspection procedure described in Section 2 to inspect your vehicle. There are more things to inspect on a vehicle with air brakes than one without them. These things are discussed below in the order they fit into the 7-step method. Illustration: Figure 5.4, title reads, Air Brake System Components and Location, Single Circuit System. The diagram is divided in different sections for tractor and trailer. Beginning with the tractor section, reading highlighted components clockwise from upper left: hand valve, foot valve, pressure gauge, highway valve, front brakes, parking brake and emergency brake valve, yellow, tractor protection valve, parking maxi brake spring valve, tractor parking brake valve, blue, safety valve, main reservoirs, the upper marked dry, the lower marked wet, low pressure warning buzzer and switch, one-way check valve, compressor. On the trailer side of the system, reading clockwise from the upper left, quick release valve, trailer brake chambers, trailer reservoir, emergency relay valve, glad hands, marked service and emergency. Continuing with the text. 5.3.1. During Step 2 engine compartment checks, check air compressor drive belt if compressor is belt-driven. If the air compressor is belt-driven, check the condition and tightness of the belt. It should be in good condition. 5.3.2. During Step 5 walk-around inspection, check slack adjusters on S-cam brakes. Park on level ground and chock the wheels to prevent the vehicle from moving. Turn off the parking brakes so you can move the slack adjusters. Use gloves and pull hard on each slack adjuster that you can reach. If a slack adjuster moves more than about 1 inch where the push rod attaches to it, it probably needs adjustment. Adjust it or have it adjusted. Vehicles with too much brake slack can be very hard to stop. Out-of-adjustment brakes are the most common problem found in roadside inspections. Be safe. Check the slack adjusters. All vehicles built since 1991 have automatic slack adjusters. Even though automatic slack adjusters adjust themselves during full brake applications, they must be checked. Automatic adjusters should not have to be manually adjusted except when performing maintenance on the brakes and during installation of the slack adjusters. In a vehicle equipped with automatic adjusters, when the pushrod stroke exceeds the legal brake adjustment limit, it is an indication that a mechanical problem exists in the adjuster itself, a problem with the related foundation brake components, or that the adjuster was improperly installed. The manual adjustment of an automatic adjuster to bring a brake pushrod stroke within legal limits is generally masking a mechanical problem and is not fixing it. Further, routine adjustment of most automatic adjusters will likely result in premature wear of the adjuster itself. It is recommended that when brakes equipped with automatic adjusters are found to be out of adjustment, the driver take the vehicle to a repair facility as soon as possible to have the problem corrected. The manual adjustment of an automatic adjuster should only be used as a temporary measure to correct the adjustment in an emergency situation, as it is likely the brake will soon be back out of adjustment, since this procedure usually does not fix the underlying adjustment problem. Note: automatic slack adjusters are made by different manufacturers and do not all operate the same. Therefore, the specific manufacturer's service manual should be consulted prior to troubleshooting a brake adjustment problem. According to the National Transportation Safety Board, the manual adjustment of automatic slack adjusters is dangerous because it gives the vehicle operator a false sense of security about the effectiveness of the braking system. Check brake drums or discs, linings, and hoses. Brake drums or discs must not have cracks longer than 1/2 the width of the friction area. Linings, friction material, must not be loose or soaked with oil or grease. They must not be dangerously thin. Mechanical parts must be in place, not broken or missing. Check the air hoses connected to the brake chambers to make sure they aren't cut or worn due to rubbing. 5.3.3 Step 7. Final air brake check. Do the following checks instead of the hydraulic brake check shown in Section 2, Step 7, Check Brake System. Test low pressure warning signal. Shut the engine off when you have enough air pressure so that the low pressure warning signal is not on. Turn the electrical power on and step on and off the brake pedal to reduce air tank pressure. The low air pressure warning signal must come on before the pressure drops to less than 60 psi in the air tank, or tank with the lowest air pressure, in dual air systems. See Figure 5.5. Illustration Figure 5.5, caption reads, Low air pressure warning devices. Top illustration showing a light on the dashboard marked no air. A device with a signaling arm coming out reads low air, indicating low pressure warning. Drop arm, wigwag. Some vehicles are equipped with a wigwag that drops into the driver's view and will not stay up in place until the desired air pressure is restored. Continuing with the text. If the warning signal doesn't work, you could lose air pressure and you would not know it. This could cause sudden emergency braking in a single-circuit air system. In dual systems, the stopping distance will be increased. Only limited braking can be done before the spring brakes come on. Check spring brakes come on automatically. Continue to fan off the air pressure by stepping on and off the brake pedal to reduce tank pressure. The tractor protection valve and parking brake valve should close, pop out, on a tractor-trailer combination vehicle, and the parking brake valve should close, pop out, on other combination and single vehicle types when the air pressure falls to the manufacturer's specification, 20 to 45 psi. This will cause the spring brakes to come on. Check rate of air pressure buildup. When the engine is at operating RPMs, the pressure should build from 85 to 100 psi within 45 seconds in dual air systems. If the vehicle has larger than minimum air tanks, the buildup time can be longer and still be safe. Check the manufacturer's specifications. In single air systems, pre-1975, typical requirements are pressure buildup from 50 to 90 psi within 3 minutes, with the engine at an idle speed of 600 to 900 RPMs. If air pressure does not build up fast enough, your pressure may drop too low during driving, requiring an emergency stop. Don't drive until you can get the problem fixed. Test air leakage rate. With a fully charged air system, typically 125 psi, turn off the engine, release the parking brake, and time the air pressure drop. The loss rate should be less than 2 psi in 1 minute for single vehicles and less than 3 psi in 1 minute for combination vehicles. Then apply 90 psi or more with the brake pedal. After the initial pressure drop, if the air pressure falls more than 3 psi in 1 minute for single vehicles, or more than 4 psi for combination vehicles, the air loss rate is too much. Check for air leaks and fix before driving the vehicle. Otherwise, you could lose your brakes while driving. Check air compressor governor cut-in and cut-out pressures. Pumping by the air compressor should start at about 100 psi and stop at about 125 psi. Check manufacturer's specifications. Run the engine at a fast idle. The air governor should cut out the air compressor at about the manufacturer's specified pressure. The air pressure shown by your gauge or gauges will stop rising. With the engine idling, step on and off the brake to reduce the air tank pressure. The compressor should cut in at about the manufacturer's specified cut-in pressure. The pressure should begin to rise. If the air governor does not work as described above, it may need to be fixed. A governor that does not work properly may not keep enough air pressure for safe driving. Test parking brake. Stop the vehicle, put the parking brake on, and gently pull against it in a low gear to test that the parking brake will hold. Test service brakes. Wait for normal air pressure, release the parking brake, move the vehicle forward slowly, about 5 mph, and apply the brakes firmly using the brake pedal. Note any vehicle pulling to one side, unusual feel, or delayed stopping action. This test may show you problems which you otherwise wouldn't know about until you needed the brakes on the road. Subsections 5.2 and 5.3 test your knowledge. 1. What is a dual air brake system? 2. What are the slack adjusters? 3. How can you check slack adjusters? 4. How can you test the low pressure warning signal? 5. How can you check that the spring brakes come on automatically? 6. What are the maximum leakage rates? These questions may be on your test. If you can't answer them all, reread subsections 5.2 and 5.3.